Hello, so today we'll be solving third question from the biweekly contest 151. The question says that we will be given an array and we have to remove all the elements from the array, and there's some cost to remove the elements from the array. So basically there are two operations that we can perform. In the first operation we can consider first three elements from an array and remove any two from them, and the cost required for this operation is max of the first three elements, that is a1, a2, a3, and we could remove any two elements from a1, a2, a3. And the second type of operation is when the number of elements in the array is less than 3. In that case, when the number of elements is 1 or 2, we can remove all the elements, and the cost for that is max of the remaining elements, that is a1 or a2. So let's see how we can solve this problem. The first thing that came into my mind was using a greedy, but then as after seeing constraints I realized that if it was a greedy question, then the constraints could have been up to 10 to the power 5, and the constraints are up to 10 to the power 3, so this could be a TP question. And also I submitted a greedy submission by just taking alternative elements and skipping the one, but it failed on this case, so it was confirmed that it is a DP question. So if it's a DP question, then what are the DP states? So the DP state that I have assumed, like considered, is I and J. What I is the element that is left. Okay, let's just start considering how we will be picking the elements. Let's say in the first three elements we pick a1 and a3, and we are left with a2 in the next array. So the elements that we have are a2, a4, a5, a6, and so on. This time if we decide to choose a2 and a5, still we are left with a4, a6, a7, a8, dot dot dot. From this we could take an observation, like whatever the two elements we choose, we have someone, like after some point there could be a condition, like we could see the pattern that after some index, all the elements are occurring in a continuous manner. Like what I am trying to say is, like if we can't choose any random numbers, okay, I mean that let's say even if we would have chosen a1 and a2, still a3 to a10 were present as it is. They were in the order, they were in the preserved order. If we would have chosen a2 and a3, still except for a1, from a4 to a10 would have maintained in order. If we would have chosen a1, a2, still from a3 to a10 would have been in order. And in this array, if we would have chosen like a4, a5, a2 was out of order, but still a6 to a10 is still in order. So from this we could say that from a particular index, all the index indices are preserving the order, and only there's one index who is not in an order. So for now we will denote the element which is not in order by I, and all the elements after which all the indices are preserving their order by J. So for this test case, our I could be 2, considering the indexing is 1 based. So I could be 2 and J could be 4. J will be 4, and for this I will be 4 and J will be 6. So after this, what all options do we have? Let's say we have traversed. This means that when J is greater than v of J dot size minus 1, which does means that there are it is present at the last possible index. J is at the last possible index, and when J is at the last possible index, what are the possible values of I? I could either be smaller than v of I dot size. If that's the case, then we are having two elements, one at v of I and one at v of J. So we will return the one of the one among the max. And if I is smaller than v dot size, the, which does means that j is out of the order and we won't be considering j. So answer is v of I, because I is always smaller than j. So if I is smaller than v dot size, and if it has not satisfied this condition, this does mean that I is smaller than v dot size but j is not. So answer is v of I. And if it is not, then both v of I and j are out of order, so we return 0 from here. And this just to check if we have previously calculated this I and j value, just checking if we have previously calculated, and we return from here. And now we have three options. I am initializing it with the possible max value. And so the option one is we choose, let's say we choose 2 and 4, a2 and a4. We choose v of I and v of j. And then our next, what will be the next value of I? The next value of I will be j plus 1, because j plus 1, why we are choosing j plus 1? Because as we know, all the elements after I is always smaller than j, and all the elements after j are sorted. So we want, so j plus 1 will be here, so j plus 1 will be here, and j plus 2 will point here. I guess I was able to explain it. And then when we choose j and j plus 1, that is a4 and a5. Now I will stay as it is, only j will move to two indices ahead. So we call function I j plus 2 and b. And when we choose a2 and a5, at that time I is the one who is left behind, so we will assign j as our new I, and assign j plus 2 as our new j, and call this function. These are the three possible options we have. And then dp of ij is the minimum possible value among these three possible options, and we just return it from here and store it in our dp. And that's how I approach this solution. I hope I was able to explain it clearly. Thank you.